There's nothing wrong with doing it that way. It just, the more data I gave you, the longer it's going to take to do it that way.
If I do it that way, I definitely won't be retiring by 25.
That's right. You won't be done with this class by 25. All right, let's see. I need something to
So
write.
then this is 45.
Do I have anything? Yes. Do your work. All right, so let me catch up to myself. Oh, it's been smart to do this earlier, Jeff. Oh, well. So you put all this stuff in. And then L3 is L1 times L2, and L4 is L1 times L3. So do those numbers look familiar?
Yes.
Yes. All right. So then you should have gotten 45.89 for this, right? And this was 2410. Is that right? 2410.89. That's always neat. All right. So you should have gotten those things. Obviously, you're going to have to write all those down for me on a quiz or a test, but, just to get cut to the chase, that's what you should have gotten. I will tell you this. You ready? I'm going to tell you something I'm going to put on a test. I'm going to tell you right now something that I'm going to put on the next test. Here it comes. I will make it so that the probabilities do not add up to be 1. And that is fine because relative frequency, when you added them up, it's supposed to be what? 100% or 1. Was it always that? No, because sometimes we had to round. So I will make on the test, I'm telling you right now, that the probabilities will add up to like 0.9999 or they'll add up to like 1.0001. You with me? Why will I do that? Because some of you will memorize this shit but not do it. So this means check it. Actually check it and verify that these two things are right. This one is kind of obvious. I can't really not do that because then the thing is totally shit. You with me? Yes.
So for the question, would that be, since it's not equal to 1?
If we round, it does not have to become exactly 1. Right? Can you live with that? Relative frequency has to add up to 100%. That's true. Bam. But if we round, it could come off a little off. And we're fine with that. Do you see how both of those statements live together? I like it. If we round, things could get thrown off a little bit. Not a crazy amount. If you add them up and they come out to be 107%, nuh-uh. Right? It should be really close to 1. So I am telling you right now, I'm going to do that. So if you write sum of p of x equals 1, just because you memorize that's what you're supposed to say, you're not going to get the points because you didn't actually check it. Do you see the point I'm trying to make, maybe? Even if you don't, just do it. All right. So in this case, they do add up to be 1, right? Did you check it? It does add up to be 1. And each one is between 0 and 1. And if you want to, you can even say that in English. You don't have to say that in Mathish. That's fine. Right? So I gave you both options here. Okay, maybe. What's probably somebody thinks there'll be at least 25. We just went over that.
96%.
Yeah, you can either add all these up, but of course 1 minus this has to equal these. Please let that just make sense. 1 minus a chunk equals the other chunk. So either way you do it, you get 96%. And of course it's the 4% that's delusional. All right. Retire 21, whatever. This guy we know already directly, 45.8. Yes.
So if it did not add up to exactly 1, would we use that number instead of 1?
Beautiful. Exactly. Kick ass. If you don't, I'm not going to go crazy on that piece. I'm just going to make it not 1, just make sure you actually check things. But if you do the shortcut, you have to use the actual thing. I like it. I like your thinking. If you don't, you're okay. I'm not going to kill you on that. That's a little bit evil. Right? So a little bit more evil than I am. And so this one you already calculated. 45.89. Two things that people make a mistake. Some people think the square root of this is the standard deviation. This is just a piece of the equation. And then, of course, the other thing like I said earlier, is people forget to square that poor dude. Right? Think about it like these. Like these? These are squared pieces, right? So this should be squared to make them on the same playing ground because I haven't even taken a square root yet. Okay, I don't know. So what do you guys get on this piece? Let's see. I'm going to remind you guys how to do this nicely to yourself. Jesus, Joe. There you go, buddy. Got this here? And then you do square root of that. Bam. So I get 304,9979. And then I get 17.464. Let me stop for a minute. Is everybody... Before I do that last step, I want to show you the shortcut. Stupid calculator costs enough money. It should be able to do all this shit by itself. And it can. Where did I used to go to calculate mean and standard deviation real quick from a list of data? Stat. Calc. One var stats. And we'll do the same thing because there's only one variable here, right? Kids' ages. There's only one variable. But where's the information? It's not just in L1. The frequency is in L2. So before we kept this sucker blank, but now I've got values in L1 and frequencies in L2. Relative frequencies, right? But they're still frequencies. So if I do L1 and L2, does anything here look familiar? Oh shit, Jeff, there you go. Right? Kick ass. I like it. Maybe? No? And of course that's the part that if you can't do it, I don't care. That's just, you can use the calculator to check your work if you want to. Okay, so part D should sound very familiar. It's just got a little extra thing with it because I don't have data the same way we've been given data before. I still put the mean in the middle. If we go one step down, to where do I end up?
28.
Blah, blah, blah. And if I go one step up,
63.35.
blah, blah, blah. Okay. And so which ones do I catch? Do I catch the 25-year-old hopefuls? No. But I do catch the 40s, right? And I do catch the 50s. But I don't catch the 65s, right? If I caught all the students who thought they'd be 40 when they retire, what percentage is that already? 23%. I also caught the 50s. So what total percent did I catch? 41. Bam! 41%. So this problem's a little different because I know all the percentages. I don't have to calculate, divide by the total. I don't have to because it's already been done. Okay, maybe. All right. And people freak out about this last one. But how many total kids are in this problem? 1,200 total kids, right? Very first thing I said. Ah! What percentage think this way?
69.
Yeah, before age 65 would be all these. Well, these are 31%. 1 minus 31% is 69%. So 69% believe they'll retire before age 65. Are you guys with me? Those are the slightly crazy ones. So 69% believe they'll retire before 65. 69% of 1,200. So 0.69 times 1,200. And then, of course, whatever the hell that is. 828? 828 kids are going to have their dreams cut short because even though the recession brought our longevity down a little bit, we're going to start to go back up. So retirement age is probably going to get pushed into the 70s, 80s. Yeah, buddy. It's going to be awesome. Work until you're 93. Yes?
Is this going to be on the double quiz or?
No. The double quiz is only on chapter 3. This is chapter 4. I never do a quiz at you on something we learned the previous class. I don't know if you've noticed that. I agree with you. That's plenty. So I'm not going to keep you just because you start packing up.